fluid pressure and measurements. So the very first question says that reading of differential manometer of a venturimeter placed at 45 degrees to the horizontal is 11 centimeter. If the venturimeter is turned to horizontal position, the manometer reading will be. So we should know that for a differential manometer, the reading never changes even when we are tilting it to horizontal. It does not depend on angle of the thing, so the reading will be same. So the option correct will be option C. Next is, in an inclined manometer shown in the figure below, the reservoir is large. Its surface may be assumed to remain at a fixed elevation. A is connected to the gas pipe. A is connected to the gas pipeline, and the deflection noted on the inclined glass tube is 100 mm. Deflection is 100 mm. Assuming theta equal to 30 degrees, the angle here is 30 degrees, and the manometric fluid as oil with a specific gravity of 0.86. This is the specific gravity of manometric fluid. This. The pressure at A is the value of pressure we need to calculate. So see, pressure at A will be, we can say, if we take this point as C, so pressure at A will be equal to pressure at C, and which is something about like H mm of oil, right? And this is how much of the oil, that is 100 sin 30 because vertical column will be of 30 degree, this much, 100 sin 30 from here to here. So this is the vertical height, so which comes out 50 mm of oil. Oil has specific gravity of 0.86, so I can change it, 50 mm of oil, 50 into 0.86 upon specific gravity of water, so this much mm of water, that comes out to be 43.0 mm of water. So the correct option will be option number B. Next is, in a static fluid, the pressure at a point is equal to the weight of fluid above, equal in all direction only if its viscosity is 0, always directed downwards. So the correct option is, in a static fluid, the pressure is same at all the points. This is because static fluid, we can say that tau is, for if fluid is static, there will be no shear force, right? And this implies there will be no gradient change, du upon dy equal to 0. And if tau equal to 0, that means pressure 0. So we can say all directions, then no shear stress exists. It is same regardless of whether the fluid is real or ideal. So the pressure at a point is equal in all directions is the correct option. Let's move on to 2 marks question. So the first question is, a closed tank contains 0.5 mm thick layer of mercury. which has specific gravity 13.6 at the bottom, and a 2-meter thick layer of water lies above the mercury layer. A 3-meter thick layer of oil, specific gravity 0.6, lies above the water layer. The space above the oil layer contains air under pressure. The gauge pressure at the bottom of the tank is this much. The density of water is this much, and acceleration due to gravity is this. Value of pressure in the airspace. So first of all, what are they telling us? Let us write that. So the thing is that there is a container like this, closed tank. Okay. Now, in this tank, at the bottom there is 0.5 meter thick mercury. This is 0.5 meter, and this is Hg, which has specific gravity 13.6. Alright. Above that there is 2-meter thick layer of water. So 2-meter thick layer of water, and this water lies above the mercury. So it is H2O, which has specific gravity 1, and a 3-meter thick layer of oil. Now above this there is oil, which is 3 meter, and specific gravity of oil is also given, and that is 0.6. Now they want us to calculate, and after that the thing is given that space above the oil layer contains air under pressure. So there is air which is under pressure, let's say P. Gauge pressure at the bottom of the tank is 196.2 kilonewton per meter cube. Value of the pressure in the air space we need to calculate. So the pressure P we can write as, everything will be like, from at the bottom the pressure is 196.2 kilonewton per meter. So all the pressure here is equal to 196.2 kilonewton per meter at the bottom. So we can say that pressure at P plus your oil pressure will be rho GH, specific gravity 0.6, G 9.81, and H, height is 3, plus H2O, which is specific gravity 1 into 9.81 into height is 2, plus your Hg, which is specific gravity 13.6 into 9.81 into the height is 0.5, comes out, that is equal to 196.2 kilonewton per meter square. So after calculating, the pressure comes out to be 92.214 kilonewton per meter square. So the correct option is option number A. Next is a 3-fluid system immiscible is connected to a vacuum pump. There is a 3-fluid system, this one, and it is connected to a vacuum pump. Specific gravity value of the fluids S1 and S2 are given below, this and this. So the gauge pressure we need to calculate of P1, that means this pressure we need to calculate. Let's calculate. So the pressure at the bottom of this fluid number 2 is equivalent to your atmospheric pressure at the bottom, which is equivalent to atmospheric pressure plus this is water, right? So atmospheric pressure, this pressure plus the water pressure, right? So the pressure at bottom, we can say pressure at bottom of fluid 2 is what? It is equal to C. We have atmospheric pressure as well, and plus this pressure of water, that is height is 0.5 into 1 into your gamma W. We can simply say gamma W I can multiply 0.5 gamma W, right? So that is nothing but atmospheric pressure is given, which is 95.43, and 0.5 gamma W is 9.81, comes out 100.335 kilopascal. Right, now we know the pressure at bottom. Now let's calculate this pressure at bottom will be total of this much, right? So let's say let's calculate that. So we get that the pressure P1 plus pressure of fluid 1, that is specific gravity into 1, that means water pressure is simply the length of this thing is 1 minus 1.5 minus 1, comes out 0.5 into 9.81, plus next fluid is fluid number 2, which is specific gravity 0.95 into the length of the fluid is 1 meter. So 1 into 9.81 comes out, and that too will be equal to now 100.335. So the pressure comes out to be 86.69 kilopascal. This is the pressure at P1. Now they are asking the gauge pressure value. So the gauge pressure is nothing but the pressure P1 minus the atmospheric pressure. We need to minus the atmospheric pressure. So 86.69 minus what is the value of atmospheric pressure? 95.43. This comes out to be negative 8.73 kilonewton per meter. So the answer is 8.73 negative. Now let's calculate the next question, which is question number 6, came in 2017, and the question says that the figure shows a U-tube having a 5 mm into 5 mm square cross section filled with mercury, specific gravity 13.6, up to a height of 20 centimeter in each limb. Okay, now if 5 centimeter cube of water is added to the right limb, the new height of the mercury in the left limb will be. So now if they add some water here, this mercury will go down and it will rise here up to something. So that rise they are asking. The volume of water is given, which is 5 centimeter cube water is added. Previously it was mercury 20 centimeter here, 20 centimeter here. After adding 5 centimeter cube water, can we calculate the height of the water column? Yes, because the area is given. So this 5 centimeter cube divided by area of the tube is 5 mm cross 5 mm, right? Mm means 0.5 into 0.5 centimeter, and if we calculate it, the height comes out to be 20 centimeter.
Now if I add 20 centimeter cube of water, 20 centimeter water, let's say this much, and let's say this was the height 20 previously, and the mercury level goes down by X amount. So the total amount here will be 20 minus X. If mercury level goes down by X amount, it will go up here by X amount. So the value here will be 20 plus X. So let's say this is the datum, or else let the bottom be the datum. Alright, and let's calculate the thing now. So the pressure, because both the columns are open to atmosphere, pressure will be same. Let's say this is P1 and this is P2. So I can say that the pressure of water column is 20 centimeter. Let's change it into, or let it be like that, 20 minus X is the height into water height, right, for the pressure P1. If I say that P1 is equal to P2, 20 centimeter of water into density 1, let's say, and 9.81 is the G value, plus this thing is 20 and this thing is 20 minus X. So the mercury level is 20 minus X into 13.6 into the gamma W, that is 1 into 9.81. That will be equal to your 20 plus X, right? 20 plus X. Let us change it first into meters. So the calculation will be easy. Everything is in meters before. So I have changed it into meter. Into, this is also mercury, 13.6 into 1 into 9.81. It comes out to be 0.2. 9.81 I'm seeing everywhere same. Let's remove it. Now 0.2 plus 13.6 into 0.2 minus 13.6 into X will be equal to 0.2 into 13.6 plus 13.6 into X. Can I say that is equal to, can I say that this is positive, this is also get cancelled by this, and I get the value of, like we can say that 0.2 is equal to 27.2x. X comes out to be 7.35 centimeter, 10 to the power minus 3 meter. That means 0.735 centimeter is the value of X. So the answer will be that how much the mercury limb gets down, 0.735 in centimeter. Next is two pipelines, one carrying oil, mass density 900 kilogram per meter cube, and other water, are connected to a manometer shown in the figure. By what amount the pressure in the water pipe should be increased so that the mercury level in both the limbs of the manometer becomes equal. Mass density of mercury and G, the value is given. So now let's calculate the thing. By what amount the pressure in water pipe should be increased so that the mercury level in both the limbs become equal. Okay, so when the things are not equal, so see, when the things are not normal, then first they have given 13550 is the mass density. So the mercury specific gravity will be 13.55. And the oil specific gravity is 0.9, right? So before the thing, the pressure will at this point, in this condition, let's calculate the pressure difference. So let's say that this is pressure A and this is pressure B. This is pressure A, pressure B. Now pressure A plus 3 meters of 0.9 and minus 20 centimeter, that means 0.2 into 13.55 and minus of water level is 1 into 1.5 is equal to pressure at B, right? So I can say PA minus PB comes out. The value, if I calculate, the thing comes out to be minus 1.51 meter of water. Now in second case, they are saying that if mercury level in both the limbs of manometer becomes equal. So they are saying something that mercury level in both the limbs become equal. So this much, let's say this is the mercury. When it becomes equal, that means if mercury, they are wanting us to become equal, that means see, mercury level is 20 centimeter here, so it should remain 10 here and it should go 10 up here, right? This much will be the mercury level. Now so the water will be 10 centimeter means 0.5, so the new water level will be 1.6 meter. And because mercury level is going down from here, we definitely increased some pressure, so I can say PA plus del PB plus del P, right? Okay, now let's calculate the thing. I have drawn this in here only. So if I see, that thing will be PA plus oil specific gravity 0.9 into, now it is 2.3 minus 0.1, 2.9, right? 2.9 into 0.9, and other side it is minus 1.6 of water into 1, I can say specific, and the pressure is PB plus del P, right? If I put PB here, PA minus PB, another thing same comes out as del P. PA minus PB I have calculated. Where is that? That is minus 1.51. and this thing comes out as 1.01. So that is PB. So the value is 2.52 meters of water, that is 2.52 into 9.81, which is 24.72 kilopascal. So the correct option is option A.